Oh, geez. Good morning, everybody. Just had a fresh cup of coffee and I'm ready to go. Welcome to Tibbetts Physics. What is crappin'? Today we're going to talk about electrical power and energy. Once my highlighter starts working. There we go. So we've talked about mechanical power and energy before. Now we're going to talk about electrical power and energy. Last time we talked about energy first and then power. This time we're going to do the opposite and talk about power and then energy. So electrical power. Still capital P. And the same thing as before. It's the rate at which energy is used. The rate at which energy is used. And we'll say converted instead of used. Typically, it's converted into, so we'll say converted into heat, mechanical energy, and typically for us when we look at light bulbs, it's converted into light, which is generated from heat. Somebody remember the formula that we use in mechanical power to calculate power? Good. It was power is equal to work over time. So now we're going to develop a new formula for power using two formulas that we've learned in our electricity unit. The first formula that we'll start with is V is equal to W over Q. Notice that the power formula right now has a W in it, so let's get W by itself. We're going to do that by multiplying both sides by Q. So we have W is equal to V times Q. So that's our first new formula we're going to plug into that. Our second formula has to do with currents. Remember, current is the rate of flow of charges inside a wire. Current is equal to the change in Q over T. Notice the power formula has a T in it, so let's get T by itself, and we'll just swap the T and the I. So T is equal to change in Q all over I. So we'll plug both of these formulas into the power formula to get our new formula for electricity. So power is equal to work, which is V times Q, over over time, which is change in Q over I. The Q's cancel. We're left with V over 1 over I, and that gives us power is equal to the potential difference times the currents. And just like before, the units of power are still what? Oh, watts, sorry. Which is capital W. Now, just like mechanical power in the previous unit, there are multiple formulas for power. And we're going to have the same scenario, and it's all dependent on whether or not we know the current, the voltage, or the resistance. So to help us make even more formulas, we're going to start with Ohm's Law, which says I is equal to the potential difference over the resistance. And we're just going to plug various forms of this inside the formula, the power formula. So let's sub in I into here. So our next formula gives us P is equal to V times I, which is V over R. V times V is V squared, so power is equal to V squared over R. Okay, so we're still going to look at I equals V over R. This time, let's solve it for V. So that leaves us with V is equal to IR. Alright, so we're going to plug V equals IR back into the original power formula, except we're replacing V with IR. So that gives us P is equal to V, which is IR, so IR times I. I times I is I squared, so our last formula is P is equal to I squared R. So how do we know when to use these formulas? Well, if we look at the first formula, notice that that has V and I, so if we're not given the resistance of the wire, we'll use this one. The second formula has V and R, so if we're not given the current, we'll use the second formula. And the last one has I and R, so if we're not given the potential difference or the voltage, we use this one. Alright, now it's time to develop some formulas for electrical energy. If you remember, E is already used for electric field strength, so we can't use E for electrical energy. We're going to use work, or W. So to develop our formulas, we'll start with power from our mechanical unit is equal to work over time. And let's get work by itself. So we multiply both sides by T. W is equal to power times time. And that's our first formula. All we're going to do is take the formulas we developed from above and plug them in for power. So we'll first plug in V times I for P. So our first formula, W is equal to V times I times T. Formula number one. Formula number two, let's look at the orange one. P is V squared over R. So W is equal to power V squared over R times T. So V squared T over R. Formula number two. And then the purple one, P equals to I squared R. W is power times time, so it's I squared R T. And those are our formulas for power, and electrical energy. Thanks for watching. See you next time.